project about?
Okay, so the name of our project is an autonomous navigation robot. And what it does is it moves from one point to another within a pre-built 2D map environment.
How did you make the robot work?
So the brain of this system is called the navigation stack, where it is an open source system we could find from ROS. So what navigation stack is actually is just a software that solves the automatic navigation of a robot. So what we need to do is to extract this navigation stack and trying to make it compatible with our own custom-built robot. And we only need to supply 4 files that is custom to our robot and to integrate it with navigation stack. And those 4 files are the odometry, which specifies the location, the relative location of our robot, the transform, which gives a snapshot of each position of the robot in a map with its timestamps, the sensor, which gathers the data from the sensors and feeding it to our system, and lastly the move base, which determines what is the velocity of our robot relative in navigating within a certain environment. How did you relate the software and the hardware part of the project?
So we connected the Arduino Mega with our robot, which communicates with our ROS program, and to receive information from ROS, we use ROS serial in Arduino Sketch. And by using ROS serial in Arduino Sketch, we can publish and subscribe to specific nodes to listen or transmit information between the hardware and the software.
Harvest. So, how did you establish the connections between the robot and the computer?
Okay, firstly, as Zain and Lucas has said, that we have been using ROS. So ROS works best with the operating system of Ubuntu. So we use Ubuntu instead of Raspbian. So to establish wireless connection, we use a Raspberry Pi, and as the computer to control and give instruction to the Arduino as a microcontroller for the encoder. And to establish the wireless connection, there are a few ways that we can connect using SSH, Remina, or TeamViewer, and we found that the best for us to work is TeamViewer. And you can control both ways. We can control, once we have put the map built using MATLAB, we can control here, and also wirelessly through the main computer.
So how is the destination goal being sent to the robot?
The destination goal being sent to the robot is used by using RViz, which sends a command velocity node to the Arduino that listens for the command velocity node by subscribing to it. And once it receives that information from RViz, it'll write the angle into the servo motor, moving the robot to that specific destination.
What limitation did you face?
So the limitations of our project right now is that we're mainly using the ultrasonic sensor as a means of creating a map instead of using it to avoid obstacles.
So yeah, from the pre-built map, that's the only thing that the robot can avoid. But in real life, you can avoid something instantaneously moving. So yeah, the improvement that you can make is that getting these sensors to work simultaneously at the robot moving time.